let's go ahead and let me do a video reviewing some of what we were doing in 4.1 and 4.2. Okay. All right. So you had some questions that look like this, where they gave you a system of equations. So here's a system of equations, and they gave you some points that they wanted you to check and see whether they were solutions to the system. Okay. So the idea is you take the ordered pair that you're given. So let's do the 0, 6. Here's the work I would do. I'd plug in the 0 for x and the 6 for y on one of the equations. And when I do, I immediately can see that's not going to work because that's 0 minus 12, and that would not be 7. So I know that one's not a solution to the system because it doesn't work in the first equation. Okay? So then I try the next point, negative 5 for x, negative 11 for y, and I need that to be 7 again. So that's negative 15, that's plus 22, and I would get 7 on that one. So it checks on the first one. Okay, you need to be careful because it needs to do more than just check on the first one. So you have to take the second equation, and I'm going to take, I'm looking at this equation now, and I'm going to plug in the negative 5 for the x and negative 11 for the y, and I need that to also be true. So negative 10 minus 1 does wind up being negative 11. So that one checks on both. Now, I know that this must mean the other 2 points do not work because I understand this really well, and I know that I had 2 lines, okay? Well, that's not necessarily true. They could be coinciding, so let me take that back. I better not just immediately put in no. Let me go ahead and test 4, 7. So I'm going to put in a 4 for the x and a 7 for the y. Now that'd be 12 minus 14. So that one does not work. Then let me put in the 1 for the x and negative 2 for the y. And that one does give me 3 plus 4, which is 7. So that ordered pair works on the first equation, but I need to take that second equation. Okay, sorry. And I need to plug in the 1 for the x and see. I get 2 minus 1, that's 1, equaling negative 2. It doesn't work on the second equation. So these were both no's. Okay? So you know how to just test whether something's a solution or not. Just make sure that you don't waste time. If it doesn't work on one of the equations, like that first ordered pair when I plugged it in did not work in the first equation, there's no reason to plug it into the second equation. You know that that point is not a solution to the system, so move on. But if it does work in the first equation, you have to also make sure it works in the second equation before you say yes. Okay? All right. Now, do you remember problems that look like this in 4.1? Maybe in 4.2. I think it was 4.1. Okay, so on this one, they're asking us to use some of that vocab, that consistent, inconsistent, that sort of thing. So when I'm looking at this one, I'm noticing how here I'm going to have a point of intersection. Here there's no intersection, no points of intersection. Right? That last one. And then I'm noticing on this one that it intersects everywhere. They're the same line. Okay. All right, so the one in the middle is the usual situation. See how it has just a unique solution, and I can try to read off what that is. Let's see, it looks like it's over at negative 3 and then down 1. So negative 3, I'd put in negative 3, negative 1 in for the ordered pair, and I would have selected a unique solution. For the first one, both lines wound up being right there. So that's the case where you have really infinitely many solutions. But on the last case over here, these lines, they were parallel. They never intersected, so you'd have no solution. Now for the vocab, the idea of inconsistent versus consistent has to do with whether something has a solution. So system C is inconsistent. Okay. Both systems A and B are consistent. They have solutions. So what we need to do to distinguish those is think about whether the equations can move independently or not. And I pretty much think about it like that intersection point is almost like a pin or a nail. And that's where it's fixed. But you see, it's almost like scissors where it's fixed there, but the lines can move other than that. Okay. And then over here, I have one line and then the other line is right on top of it. So if I put pins at the intersection points, that line is stuck together. So this one has a solution, so it's consistent, but it's dependent. The equation is stuck to itself. Okay. Where over here, I have a solution, so it's consistent, but the lines can move independently. So they're independent equations. Okay. So that one takes just a little bit of critical thinking, but it's not too bad. All right, then let's look at some problems where you're being asked to solve. So you might be asked to solve by graphing. Okay, so if they gave you something like this, they gave you two equations. Here's one of them. It's in slope-intercept form. The other one's a little weird, I thought, when I looked at mine, what came up on mine. So I'm going to try to graph these two lines and then see if I can tell whether I have intersecting, parallel, or what. Okay, so you got to think about how you're going to graph y equals -1/2 x plus 3. Okay, you might just find ordered pairs that fit it, like put a 0 in for x and just work that out. Then y would equal -1/2 times 0 plus 3, so y would be 3. And then notice it has a fraction there. So if you're trying to find another good point, you should pick things that work well with a denominator of 2, like 2 itself. -1/2 times 2, that would be -1 plus 3. So when x is 2, the y turned out to be 2. All right, and then maybe a -2 would be good. If I put a -2 in for x, this would be +1 plus 3, and I would get 4. Okay. All right, so let me see what that turns out to be. So let me put some tick marks over here. You'll have, of course, the grid, and you'll just graph it on the computer. So 0, 3 would be on the y-axis at 3, 2, 2, and then -2 is at 4. And then I'm looking at how those line up, so I feel pretty good that I've got those correct. Okay. All right, so it's going to look something like that. Now, I also could have graphed by using the slope is -1/2 and the b is 3. I'd be at 3 on the y, going down 1, right 2. I kind of like graphing that way personally. Okay, but I would just get the same line, just did it a different way. Okay, now let me change colors. I'm going to do the other one in red. Now for this one, the x and the y are on the same side, so some of you might just like finding ordered pairs. So I might plug a 0 in for x, but if I did, I'd get 0 plus y, which is y, also has to be 0. So that's one ordered pair that works. Okay, let me try plugging a 1 in for x. I'd get 2 times 1 plus y equals 0. That's 2 plus y equals 0. So I can solve that equation, and I wind up with y equaling -2. Okay. So you don't really have to hesitate too much on these, because really you can just pick something for the x or the y and work it out. All right, if I picked a 2 for x, I would get 2 times 2 plus y has to be 0. 4 plus y has to be 0. So when I subtract 4 from both sides, I get y equals -4. So I get 0, 0, 1, negative 2, 2, negative 4. So that seems to be lining up. Okay, I'm going to go up 2 and left 1. Okay, so then I would wind up having something that looks like that. And I have a real messy graph, so it's going to be hard for me to see the point of intersection from the graph. So I'm going to try to guess it, but I bet I might guess wrong and have to go back and check again. Okay. So it looks like it's going to have like a negative 2. I don't know. It's kind of looks like it's over at negative 2, maybe up 4 or so is what I'm thinking from my picture. By the way, before I go on, that equation, if you like to graph using the slope and the intercept, you could have taken that equation right there and worked on getting the y by itself by moving the 2x out of the way. And then you could say, oh, the slope is negative 2. And see, the b value is understood to be 0. So you could start at the origin and then go down to the right 1, down to the right 1, and get your line graphed. Okay, but back to my graph. So I'm supposed to be solving the system by graphing. So after I get it graphed, I have to look and see if I can figure out the intersection point. It looks like maybe a negative 2, 4. So I'm going to actually try that in these equations to make sure it's on both of them. So if I put a negative 2 in for x, okay, do I get the y to be 4? Negative 2, right? I'm putting in. So negative times a negative would be positive. That's 1 plus 3. So that point is on the first equation. That's true. And then I'm going to check the second equation, which is 2x plus y equals 0. If I put in a negative 2 for x and a 4 for y, do I get 0? Negative 4 plus 4 would be 0. Okay, so now it's not a question mark anymore. I verified it. So that's going to be the solution. So solve by graphing. You just graph the two lines and then look for where they intersect. Okay? All right, so now let's try. Let me see if I can get another page down here. Might have to open a new. All right, so now what if you were asked to solve by substitution? Okay, let's try this question. Y equals 2x minus 5 is one of them, and negative 5x plus 3y equals negative 13 is the other equation. Okay, and then we'll do another problem by substitution. So let me go ahead and write it down. Okay, so I'm being asked to solve by substitution. So I would look for one of the variables to be by itself. So this problem already has the y by itself. So I know the way substitution works is I'm going to take the y in the other equation. It should be the same as at the point of intersection. And then I'm going to plug that 2x minus 5 in place of that y. So I'm going to have negative 5x plus 3 times, and in place of that y, I'm going to put 2x minus 5. Okay, so take a moment, pause it if you need to, and think about that. That's the key step. That's the idea behind substitution. Okay, now from here to the end, I'm just working on solving an equation like we did in chapter 2. We'd have negative 5x plus 6x minus 15 equals negative 13. These are on the same side. They're just like terms I'm going to combine, and I'll get 1x, or x, when I combine them. So those get put together. Now I'm going to add 15 to both sides, and I get x equals 2. Be careful about all your positives and negatives. Okay. Now, I'm not supposed to just get x. I'm supposed to also get y. So I'm going to go back, and I'm going to take that equation that had the y on a side by itself, and right there where x is, I'm going to put a 2, because x and 2 are the same. So right there where x is, I'm going to put a 2. So I'm going to do 2 times 2, take away 5. So that would be 4 minus 5. That would be negative 1. So x was 2 and y was negative 1. Now you can be sure you're right on this one by taking, since I used the first equation to find the ordered pair, I'm going to use the second equation as my check. So I'm going back to that second equation and I'm plugging in the 2 and the negative 1 and making sure I get negative 13. So I get negative 10 minus 3, that sure enough would be negative 13. So it checks, okay? All right, so that's your answer. Now on Alex, it looks like they're asking you just to plug in for the x and then plug in what you get for the y. I wish they would ask you to do the ordered pair. All right, so that's solving by substitution. I was kind of surprised that this last question was pretty much set up the same way. It already had a variable by itself, so it's pretty much the same concept. I'm just going to put 2x minus 7 in place of the y. Okay. So I'm going to put a 2x minus 7 right there. And then I've got a chapter 2 type problem. So I'm going to take 3x, that'll be minus 4x plus 14 equals 11. That would be negative 1x plus 14 equals 11. So I'm going to subtract 14 from both sides, which gives me a negative 3 equals a negative 1x. And then to get rid of that negative, I'm just going to divide by it like I would if that had been a 2x out in front. I would have just divided by it. So that gives me x equals negative divided by negative would be positive 3. Okay. So I know my x. The best place to plug in to get my y would be y equals 2x minus 7. Right there, I'm going to put a 3 because x is 3 and work that out, and I get negative 1 for my y. So the answer should be 3, negative 1. Okay, so if you've got time to check it, you can just go back to the equation you didn't use and plug in a 3 for the x and a negative 1 for the y. So that's 9 plus 2, which does equal 11. It checks. So you know you're right. Okay. So I just wanted to do a quick review of some of the stuff in 4.1 and 4.2 because you're going to have a quiz on that on Thursday. But I also need you to be working on completing homework, the rest of the homework as well. Go on and do 4.3 as well.